You ready for things to get crazy? If you said yes, then keep watching. If you said no, then go back and watch previous videos. You can watch the more basic ones. Okay, number one, what are we going to look for? GCF. Do you see a GCF? Okay, what goes into 2? 2. What goes into 21? Not 2. What goes into 10? 2. Okay, here's the deal. There is not a number other than an understood one that can divide out of all three of those, so no numerical GCF. Also look for variables, x squared, x, and no x's at all. No GCF. We are now down to step 2, which is to factor a quadratic trinomial. And so at this point, we're going to proceed with what we've been doing, but we're going to notice that there is a problem. And here is our problem. Okay, two numbers multiply to give me 10. That would be 1 times 10. It would be 2 times 5. I would talk about negatives, but let's not, because there are no negatives in the problem, so we won't need any negatives. Try them if you want to, but it won't get you anywhere. So what I want to do is be able to add these and get a 21. And good luck with that. So if you add 1 plus 10, you get 11. If you add 2 plus 5, you get a 7, and you're not going to get your 21 out of this deal. And here's why not. This 2 in the front needs to be considered. Okay? So as we begin to break this up into separate things, this strategy is flawed. And I'm going to teach it the way that I've been taught. There are other ways of doing this, but a personal opinion. I think that teaching this the way you're about to see it is going to help us understand binomial multiplication even more, and just solidify some of our understanding on that. So let's talk about 2x squared for a second. Well, first of all, if this 2 wasn't here, we would just call it x times x, right? But it's 2x squared, which means, all right, 2 numbers multiply to give me 2, and you can go all crazy with this one as well. You can be like, 2, well, that would be 1 times 2, and you're right. So yeah, it is. So you can put a 1 and a 2 and a 1 and a 2. There we go. So we have x times 2x, and it's going to give me 2x squared. Now, is the 2 here? Is the 2 there? It really doesn't matter. Okay, I'm going to leave it the way it is for now. So at this point, I'm going to go into experimentation mode, which means if you were writing with an ink pen, don't, because we're probably going to get it wrong. All right, so I'm going to switch to red until we know it's correct, and then I'll write it in black. All right? So I'm going to just start grabbing numbers over here and throwing them in the appropriate places and seeing if it's truly the appropriate place. So let's do 1 and 10. Okay? Now, they are positive, so we'll do plus 1 and plus 10. If this multiplies out to give me that, I have to check my answer. To give me 2a squared plus 21x plus 10, we're good. If not, we're going to have to try 2 and 5, or we're going to have to reverse the order of those. Okay? There's all kinds of things. So I could do 1 and 10, I could do 10 and 1, I could do 2 and 5, I could do 5 and 2. We'll talk about that. Okay, let's multiply all this out. Again, writing in red, so don't write it because I might be wrong. So x times 2x is 2x squared. X times 10 is 10x. 1 times 2x is 2x, and 1 times 10 is 10, which gives me 2x squared, 12x, and 10. All right, yay! First term's good, last term's good. They always will be if you pick the right factors. Well, if you pick factors of those specific numbers. But the middle term, that 12x needs to be a 21. Something's wrong. Okay, so this was wrong, and we're going to have to fix it. And here's what I do much faster. So, and you please do this too. Multiply those, add those together. So 10 plus 2 is not 21. Also, can I show you something else? If you were to write it like this, notice this set of parentheses. There's a GCF over here of 2. There is not going to be a GCF in this problem. We already determined that. So anytime you set this up and you notice that there's a GCF in one of the parentheses, you're wrong automatically. It sounded like a criticism. You're wrong automatically. But a GCF of 2 would create a GCF in the original problem, and we didn't have one. So let's not. Good to know. Now you know. And knowing is half the battle. G.I. Joe. Okay, let's, what do you want to do? Do you want to do 2 and 5, or do you want to switch the 1 and the 10? Let's switch the 1 and the 10. Not with an eraser, you won't. There we go. 10 times 1, maybe I'm right, maybe I'm wrong. Okay, let's just go ahead and go for the obvious. 2x squared, that's going to happen. 10 is going to happen. We'll put pluses in there. And so then if we multiply these, we'd have, in your head, 1x multiply these, you'd have 20x. 20 plus 1 is 21. We got it. Sorry, I clapped right in the microphone. Like, no. Okay, we got it. We found it. This is correct. So if you want to write it in whatever permanent color you want to write it, then feel free. I believe that I will write it like that. It's going to drive you nuts, isn't it? Like, oh, don't do that. Oh. What I could do is erase the part underneath here. Let's do that. Watch, this is going to be perfect. Got it, except for that one part right there. Okay, that is it. That's it. The answer right there. Let's fix that, make it look like a plus, not a multiplication symbol. All right, let's do one more like this. I'll lie. Let's do two more like this in this video. So we're going to do the next two problems. If you're following along with the notes, it's the next two. And it is going to be 12x cubed plus 38x squared minus 14x, and let's start with GCF. Is there a greatest common factor? Okay, let's look at the numbers. 12, 38, and 14. What goes into 12 that also goes into 38? 2, okay? So does 2 go into 14? Yeah, okay. Is that the biggest thing that I can divide out of 12 and 38 and 14? The answer is yes. Nothing else any larger divides out of 12, 38, and 14. So we're going to factor out of 2. And look at variables. X cubed, x squared, x. They all have an x. So now it's just a matter of how many can I take from each one. And I'm going to take the lowest exponent, which is an understood 1. So we're going to do that. That means 12 divided by 2, 6x squared, because 3 minus 1. 38 divided by 2, that's 19x. And then 14 divided by 2 is 7. Okay. Now we're into some strange territory here. If you look at your list, GCF, check. Quadratic, trinomial, let's do it. Let's tackle it. Let's keep going. So 2x, and then, whoops, there we go. We'll do this. Now, on the previous problem, as seen here, we had a 2 in the front, and that 2 is prime, which really limits our options of what would multiply to give us the 2. In this case, the problem we're working on now, there we go. The number in the front, I'm not talking about this 2, I'm talking about the 6. This is not a prime number, this one is. Now, sometimes they won't both, neither one of them will be prime and things get really tricky. But for now, we'll start with this. So 6 is, well, 1 times 6 or 2 times 3. Okay? 7, more appropriately, negative 7 is 1 times 7 or 1 times 7. Let's change some signs. Make one of them negative in each one. Okay, so we have negative times positive giving us a negative. So here's what I want to do. I want to figure out how to get a 19 out of the middle of this thing. Don't ignore the 2x, just hangs around. It is not going to be part of what we're doing, but don't fail to write it because it was part of the larger problem. And it doesn't just vanish. It doesn't just go away. Not in this context. So what I want to do is go ahead and write down what I do know. And here's what I do know. X squared is x times x, but we're probably going to have something in the front. Now, is that something a 1 and a 6 and a 1, a 2 and a 3 and a 2? I don't know. But here's what I do know. This is going to be 1 and 7. What if it's 7 and 1? It really doesn't matter. Let's just go ahead and set those. We're going to set a 1 and set a 7. Now, which one's positive, which one's negative? I don't know. We'll deal with that in a minute. What I am going to do now is start experimenting with what I don't know. So I'm switching colors, and if you're writing in ink, then stop it. So you take a guess, and you say, all right, do I want to use 1 and 6 or 2 and 3? Or actually, do you want to use 6 and 1 or 3 and 2? I'm going to go 3 and 2, and I might be right. Wow, that was a random guess, and it is right. But let's go with it. Okay, 3 and 2. It was really a random guess, and I was like, oh, that's going to work. Okay, so let's do it. I still haven't decided where my signs go, okay? So somebody's positive, somebody's negative with the 1 and the 7, just don't know which ones yet. But if I were to multiply these two together, I'd have 6x squared. Check. If I multiply these together, I'll get a 7. I need different signs. We'll get there. But if I multiply these together, I'd get 21x. If I multiply these together, I'd get a 2x. And you've got your 19. 21 minus 2 is 19, which means this product needs to be negative. So I'm going to make the 1 negative, which means I'm going to have to make this one positive, and this is going to work. This is it right here. Let's erase. Let's erase all the extras, and let's just go and erase those as well. And then we'll put the final answer in black. That was a 3, a 2 there, a minus, and a positive there. And it works. You can multiply the whole thing out, and it'll take you back to there. And if you do multiply the whole thing out, I recommend you do this, and then distribute the 2x. You don't have to, but it's just how I think it works best. Okay, let's do one more in this video, and it's going to be crazy. 10x squared plus 20x plus 10. Actually, it's not as crazy as you think. This was actually one of the categories that my Algebra 1 teacher put on the list, and I took this one off because it fits into another category as well. And I like it, but I don't treat it like an extra, a separate type of problem. Okay, GCF. Well, variables, no, so they don't all, not all terms have an x. I say they. Who's they? The terms. Not all 3 terms have the same variable. That one has no variables. But everything is divisible by 10. Every term is divisible by 10. So we're going to divide every term by 10. That gives me x squared, 2x, and 1. And so this is the product. So let me rephrase that. It is a binomial squared. You'll see where we're going with this in a second. But 10, and then we're going to do that. So we have a trinomial. In case you care, GCF was first thing to look for. Second thing to look for is a quadratic trinomial, which we have done. And so x times x. And then I need 2 numbers that multiply to give me 1. Well, your options are very limited. I think it's 1 times 1, okay? Now, you could play with -1 times -1, but don't, because it's useless, because you have no negatives in this problem whatsoever, and you want to be able to add and get a 2. Notice that there's not a number in the front here other than an understood 1. So all the craziness we had just played with like, oh, I got to factor this and work it out, not in this one. Not in this one at all, okay? There's an understood 1 there, so x squared is just x times x. That's it. That's that simple. 1 plus 1 is 2. -1 plus -1 is -2. I don't want that one. I want this one. So final answer, x plus 1, x plus 1. This is not wrong. I like it. I like it very much, but I'm going to write one more step. Just so we understand the power of exponents. That's a bad joke. Anyway, there we go.